Hello and welcome to Networking with Louis. In today's video, we'll be discussing ACL. ACL, which is short for Access Control List. It's a security mechanism we use in networking to filter and control how traffic goes in and out of our different networks. So in today's topology, we'll be discussing and I'll be showing you the step-by-step process of configuring ACL. But before that, I will also configure RIP routing protocol. So in today's video, we'll be doing RIP routing protocol and we'll be doing ACL in this video. So let's get to networking. The first step would be to configure the IP addressing accordingly. So I'm going to go to my router 0. I'm going to use enable config terminal to go into the global configuration mode, and I'm going to configure the IP addressing accordingly. So interface gigabit 0/0, IP address 1.0.0.1, 255.0.0, no shutdown. Right, you can see the amber light came up, and I'm also going to configure for this other interface of that router, interface gigabit 0/2/0. Let me be sure of the interface number 1/0. IP address 27.0.0.1, 255.0.0.0. No shutdown. Exit. So I've configured IP addressing on router 1, so I will proceed to router 2. Interface gigabit 0/1/0, IP address 27.0.0.2, 255.0.0.0. No shutdown. Exit. Interface gigabit 0/0, IP address 2.0.0.1, 255.0.0. No shutdown. Okay. And I'm also going to configure this part. Exit. Interface gigabit 0/2/0, IP address 54.0.0.1, 255.0.0.0. No shutdown. Exit. So we'll move to router 2. Interface gigabit 0/2/0, IP address 54.0.0.2, 255.0.0.0. No shutdown. Exit. Interface gigabit 0/1/0, IP address 19.0.0.1, 255.0.0.0. No shutdown. Exit. Interface gigabit 0/0, IP address 3.0.0.1, 255.0.0. No shut. Exit. And finally, router R3. Interface gigabit 0/0, IP address 4.0.0.1, 255.0.0.0. No shut. Exit. Interface gigabit 0/1/0, IP address 19.0.0.2, 255.0.0.0. No shut. Exit. Alright, so I've done the first step, which is to configure IP addressing across all routers. The next step I want to do is configure DHCP server so that all these end devices can obtain IP addresses dynamically. So I'm going to go into each individual router and make that router DHCP server. So using the Cisco command IP DHCP pool, then any name of my choice, I would say R0 network 1.0.0. So mind you, the network you use for your DHCP server would be your local LAN network. the network facing your end devices, because that would be the gateway by which they go to the network or they go to the internet. So network 1.0.0.0.255.0.0.0. Default router 1.0.0.1. Exit. And let me verify that these PCs can now obtain IP address automatically. You see, that's obtain an IP address of 1.0.0.2.255.0.0.0 and the default gateway of 1.0.0.1, which is the IP address of this router, that interface of the router here. Okay, so I'll proceed with these PCs, and you see they've all obtained IP address here. Okay, so for the sake of time, I'm going to just fast forward this process. I'm just going to pause this video right now and finish up with the IP addressing and DHCP server configuration. All right. So now all the end devices have been configured to obtain IP addresses automatically or dynamically, but you would understand that only local IP addresses can ping themselves. For instance, on this 4.0.0 network, only devices having that IP address block or subnet can ping themselves. So PC8, whose IP is, if I use ipconfig, I'll see PC8 IP configuration. PC8, whose IP is 4.0.4, can ping 4.0.0.2, and you can see it's pinging successfully. It can also ping 4.0.0.3, but it cannot ping the device in 3.0.0 network. So PC8 cannot ping any of those devices because they belong to different networks. For example, server 2's IP is 3.0.0.4. If I try to ping it from PC8, ping 3.0.0.4, you see the message destination host unreachable. So it cannot reach that host, which is the server 2. Now, to help us reach that host, we need to configure routes or routing. It's either we do a static route or we do a dynamic route. In my earlier video, I've done a video on static routing. So in today's video, I want to treat RIP routing. So RIP routing is short for Routing Information Protocol, right? So I'm going to configure RIP routing and I'm going to show you the easy steps. RIP is the oldest of the dynamic routing protocol and it's the easiest to configure and manage, although it has a limitation of limited number of networks that it can take. So RIP is not good at scalability because it has a metric which uses hop count. So when the networks exceed about 15 hops, then RIP can no longer support such a network. So the reason why I am adopting RIP protocol or RIP routing here is because I have just about 4 routers. So this is still within the strength of RIP. All right. So I'm going to show you the steps of configuring RIP routing. Going to my router 0. The Cisco command says router RIP. Then I'm going to state the version 2. Then I'm going to advertise the network. So I'll be advertising all the connected and local network. What I mean is this: for router R0, the connected and local networks include this and this. While for router R2, for example, the local and connected networks include this, and this. And similarly for router R1, the local and connected network include this, and this. Alright, so I'll be advertising the routes local and connected. So I am on router 0, network 1.0.0.0. You would understand that RIP does not use subnet mask or wildcard mask. You only specify the network, and it does a classful networking. So at the end of advertising networks, I'm going to use the keyword no auto summary because I don't want it to auto summarize my network. Because if I have subnets within that network, it's going to auto summarize it, and it could lead to some form of packet loss in more complex networks. So I'm going to advertise the second network, which is the 27.0.0.0. Then I'm going to do no auto summary. When I save, that's basically how to configure RIP. So I'm also going to repeat the exact same step on R1. So router RIP, version 2, network 2.0.0.0, network 54.0.0.0, network 27.0.0.0. No auto summary. And I'm going to save it. Now that I've configured RIP routing, let me verify if this router has learned any RIP route. So I can do that by checking my routing table using do show IP routes. And you can see I have a route that says R, which represents RIP from here. So I have this a new route. What this implies is that devices within the 2.0 network can now communicate with devices in the 1.0 network. So I can test that out using ping from the router's interface 1.0.0.2. And you see the ping was successful. Also, I can test that on the device themselves. I can try to ping. So this guy's IP is 2.0.0.3 and I want to ping 1.0.0.3. And you see it is successful, right? ARP failed the first time, but the subsequent pings were successful. So basically, I've established the routing protocol between these two, and they can communicate to themselves. So I'll go ahead and establish routing protocol for R2 and R3 respectively. Okay. So going to R2, router RIP, version 2, network 3.0.0.0, network 54.0.0.0, network 19.0.0.0. No auto summary. Save. And finally for R3, router RIP, version 2, network 4.0.0.0, network 19.0.0.0. No auto summary. Save. Okay, so I can exit and I can verify on my routing table if RIP route has been learned on this router. So using the command do show IP routes. See, RIP has not populated its route on this particular router, so we'll give it a bit of time. We could also fast forward the time a bit, to save us time, and we'll try that command again. And now you see RIP has populated its routes on R3. So right now R3 can ping every device. Also, the devices within R3, which is within the 4.0.0 network, can also ping every device on the networks, right? So we could verify using do ping, for example, 2.0.0.2, and you see it was successful. Also do ping 1.0.0.3, successful. Do ping 3.0.0.3. And you can see successful also. So it means at this point, all the devices, they can ping themselves from wherever they want. So I could go back to PC8 where the ping failed earlier on and try to do that ping again and see if this time the ping will be successful. You know, earlier on we tried to ping 3.0.0.4 and it said destination host unreachable. So let's try it again and see. Ping 3.0.0.4. See, ARP failed again the first time, but the second, third, and fourth, it's pinged successful. So basically that's how to configure routing, and at this point, you know, we've configured RIP routing. Now, I could also show you how to configure ACLs. ACLs.